Welcome to our first lesson in Chapter 15. Chapter 15 is going to be all about water. So this first lesson is just like an introduction to water worldwide and kind of locally. So learning goal or learning objective here is that you'll be able to describe the basic concerns that we have with water use as well as the water cycle. So you should have gone over the water cycle at some point previously in your science learning, but we will go over it today. All right, so learning goals for today, there's just a couple. So explain how water is cycled through the hydrologic cycle, aka the water cycle. Explain the significance of groundwater, aquifers, and runoff, and also know the difference. And then explain how land use affects infiltration and surface runoff. So at the end of this lesson, you should be able to do those things. So let's look at the global water challenge. So global freshwater resources are threatened by rising demands. Populations are rising. That means we have more people. If we have more people, that means we need more water for all of the things that we use water for. So growing populations need ever more water for drinking, hygiene, sanitation, food production, and industry. And climate change is expected to contribute to more droughts. Policymakers must figure out how to supply water without degrading the natural ecosystems that provide it. Because remember, we don't have clean water without the natural ecosystems that help filter it and cycle it and do all the things that we need ecosystems to do with water for us to survive. So the water issue. Water is the material that makes life possible on Earth. When we look out into the solar system and we're looking at other planets to see if life is possible, one of the main things we are looking for is water. Water has remarkable physical properties. So water molecules are polar, which means that one side is slightly positive and then one side is slightly negative. So because of that, they're like little magnets that like to stick together. They can also separate other molecules from each other. So because they're polar, they kind of like help pull things apart. Water also stores heat really well. It takes a lot of energy to change the temperature of water. So once you change that temperature of water, it helps kind of hold that in. Water quality is just as important as its quantity. You could have, a lake full of water, but if it's dirty, nasty water or salty water, that doesn't help us in terms of like water to drink. So 70% of Earth's surface is covered by water in the form of oceans. Oceans represent 97% of all of the water on Earth. Of Earth's fresh water, so 3% of all the water, only a tiny fraction is actually available for us. And potable water or potable water is unpolluted fresh water suitable for drinking. So sometimes if you've gone camping, campsites will say they have potable water. That means that you can cook with it and you can drink it. Shortages can be directly attributed to human-induced water pollution. We do not have a water shortage because natural things have happened and oh no, we're just running out of water. We are running out of water because we have caused it. So continuing with the water issue, the World Health Organization, or the WHO, estimates that 10% of the world's population does not have access to safe drinking water. According to the UN Environmental Program, between 5 and 10 million deaths occur each year from water-related diseases, including cholera, malaria, dengue fever, and dysentery. So 5 to 10 million people are dying because they don't have clean water. That means that there's millions more that are getting sick because they don't have clean water. These illnesses have been increasing for the past decade, and without economic investment in safe drinking water supplies, the rate of increase will continue. This is a human-caused issue. It can be a human-led solution as well, but it means people with the money putting that effort in fixing it. So if we look at our freshwater resources, so up here, this top pie, this might be really tiny depending on what screen you're watching this on, but this up here is all water. So this light blue is oceans. It's 90, 97, 98%. This tiny little blue sliver, this is fresh water. And so you might be able to see the big chunk, so 2% of that is ice and glaciers. 0.5% is groundwater, 0.02% is rivers and lakes, and 0.01% is in soil. And we can see that kind of spread out here. So this chunk down here is just a bigger representation of this tiny slice. So ice and glaciers, 78% of that 3% of fresh water we have. Groundwater is 21%, rivers and lakes is 1%, and soil is 0.5%. So areas of the world experiencing water stress. The darker the blue, the less stressed. The darker the red, the more stressed. So areas where there's, snow, there's not going to be as much concern because you've got water there. But areas that are a little bit more desert-like or have less economical resources are going to see more water stress. All right, moving on from issues with water to the water cycle. This is a really simple graphic showing the water cycle. But all water is locked into a constant recycling process called the hydrologic cycle. So we're not creating and destroying water as we're going through and consuming it. All the water that is here is the water that's been here. Now those molecules can break down into other things, but the same elements and atoms that were here a million years ago are the same elements and atoms that are here now. So it's just cycling through constantly. So solar energy is the energy input that causes this cycle to start. So solar energy evaporates water. So this is when the water is going from the ground up into the atmosphere. Evapotranspiration, or just transpiration, is the process of plants giving off water. So these trees are also giving water back into the atmosphere. It is technically evapotranspiration, but just fair warning, I will typically just call it transpiration. Warm, moist air rises, cools, condenses, and falls as precipitation. So evaporation is just those water molecules going up into the atmosphere. Clouds are as it's condensing, and as it condenses and condenses and condenses, and there's more water up in the atmosphere, then it causes rain, precipitation, which could be rain or snow or hail or sleet. Some precipitation remains on the surface and evaporates, while most sinks into the soil or returns to the oceans. So some of it is just going to sit on the surface and pretty quickly evaporate, especially depending on the temperature outside and the climate. Some of it will infiltrate or percolate down into the soil. And if there is like asphalt or cement, then it's going to run off. So runoff is when it's not infiltrating into the soil. So runoff is a surface water that moves across the surface of the land and enters streams and rivers. So when we look at a street like this, the water can't be, it's not getting sucked into the street. It's just running off the surface and going, if it's well planned, into drains or maybe flooding, as we see all the time in Tulsa. Groundwater is water that fills spaces in the, in the substrate. So substrate being what is below us. So filling the spaces in the soil. And the water entering the soil is either taken up by plant roots or moves downward until it reaches an impervious layer of rock and accumulates in porous strata called an aquifer. So an aquifer is the place where the water is held. So this is another graphic showing that hydrologic cycle. So an aquifer is an underground layer of gravel, sand, or permeable rock, permeable meaning water can get into it, that holds groundwater that can be extracted by wells. So you may, or will, be asked the difference between an aquifer and groundwater. An aquifer is what is holding the water. It is the vessel that holds the water. The groundwater is the actual water that is underground. An unconfined aquifer is usually really close to the land's surface, so really easy for us to like dig a well and get into. The top layer saturated with water is the water table. So with tables, we have a table top. So the water table is the top of the water that's underground. The lower boundary is impermeable layer of clay or rock. Impermeable meaning water cannot get through it. The vadose zone, or zone of aeration, is the area above the water table unsaturated with water. So we have the surface, we go underground, and we're in the vadose zone until we hit that water table, and then that area is an aquifer, and the water that's there is the groundwater. The water in these aquifers is at atmospheric pressure and is recharged by rainfall and percolation. A confined aquifer is bounded on top and bottom by layers impermeable to water. So water is not escaping. These are confined, and they are usually longer term storage. So water in these aquifers is stored under high pressure because it's stuck in there. And it's recharged by rain and surface water from a geologic recharge zone. The impervious confining layer is called an aquiclude. It's like excluding the water from leaving. The permeable confining layer is called an aquitard, so it's slowing the water, like it's hard for the water to get through. And then porosity is a measure of the size and number of spaces in the substrate. So if it has high porosity like sand, a lot of water is going to be able to be held. If it has low porosity like silt or clay, then it's not going to hold as much water. So there's different layers and the different types of aquifers. So aquiclude at the bottom, the water cannot get through it. This layer also is an aquiclude. So this water here can't go up, can't go down. It's confined in this space, and there's a hole somewhere where the water is being recharged from the surface. And then this is a semi-confined aquifer. It's confined on the bottom, and then it has an aquitard, which just means it's really hard for the water to get through, but it could very slowly. And then unconfined is just really close to the surface. And this is a typical well. These are artesian wells that go a little deeper. All right, so human influences on the hydrologic cycle. We have had quite a few, but first, let's focus on runoff and infiltration. So runoff and infiltration rate are greatly influenced by human activity because we are changing the land. We are changing the ground and how water interacts with it. So a major concern in many urban areas is the transportation of stormwater. People get paid a lot of money to plan stormwater. They can be stormwater engineers. Like they have to plan in the city how all the water is going to flow. Because if it's not well planned, like in some parts of Tulsa, then we get flooding, and that's not good. So water withdrawals are measurements of the amount of water taken from a source, and then water incorporated into a product or lost to the atmosphere through evaporation or evapotranspiration cannot be reused in the same geographic area and is said to be consumed. Just two little tidbits here. All right, before you move on to mastery, can you describe the hydrologic cycle? Because I hope so. But if you can't, please ask. Let's talk about it, or you can rewatch the part of this video that covers that. If you have any questions, please let me know, and I will see you in the next one.